We're continuing on now in chapter 23, moving into some of the causes of diarrhea. All right, so we'll spend a good bit of time talking about diarrhea, which is one of the most common GI diseases. So we'll talk about acute and then a little bit about chronic. So acute diarrhea, just defined by 3 or more loose stools in a 24-hour time. Of course, huge incidence. It's estimated every person will get at least 1 bouts of diarrhea throughout a given year. It is 1/3 of those cases are actually transmitted from contaminated food. So some are just from an infection, some are from contaminated foods. And just to put it into perspective, about 700,000 children die from diarrhea, mostly in developing countries. So thankfully, in developed countries like the US, people typically do not die from diarrhea, but just to put it into perspective, this is a life-threatening illness for many throughout the world. So to put that into perspective as well, our 5 most common causes of foodborne illness. Again, about 1/3 of the cases of acute diarrhea is from food. And norovirus is the most common, especially cruise ships are more prevalent to these. But again, foodborne illness, the most common is norovirus. Now, the one that is kind of the deadliest, most likely to lead to death, is salmonella. So we think about that like with chicken and eggs, but salmonella, of all those that can cause acute diarrhea, is more deadly. Now, talking then a little bit more about salmonella, we won't go through every organism that can cause acute diarrhea. I'm hitting on a few though. So salmonella gram-negative, so it has that lipopolysaccharide, that endotoxin, but there are some different serotypes to it, and it's based on their surface antigen. So there's the antigen H, K, and O based on what it's actually making. So H is the flagellar antigen to make the flagellin, make it motile. K is the capsular, so it can produce that capsule that allows it to attach. And then O is a cell wall antigen, and again, it helps make a part of that lipopolysaccharide that's found in our gram-negative cells. So there are some variations in different serotypes among the different types of salmonella. So the causes, again, a variety of diseases in about 1 million cases, again, about 400 deaths per year. So norovirus is the most common, but kind of salmonella is the most deadly of them. It leads to a couple things: salmonella osis, which is that gastroenteritis, so the infection of the GI system, and that can be mild, just from vomiting and diarrhea, to septicemia, which would then lead to death, so the escape of those microbes into the blood system. Salmonella, in addition to acute diarrhea, can also cause typhoid fever. Now, into the E. coli, which is commonly what we think about. We hear about contaminations of foods and stuff like that, and we talk a lot about E. coli with diarrhea. So E. coli definitely part of our normal flora, but when it gets to places it shouldn't be is when we get problems. There are several types, though, of E. coli. So the one we're talking about here, STEC, which is Shiga toxin producing Escherichia coli. It's also called O157H1. Again, those are the serotypes. So the O antigen, the H antigen that's making those various antigens. Again, they're numbered. So we have lots of these kind of strains of E. coli based on which antigen they have. So this STEC, again, can be mild gastroenteritis or inflammation that has a fever to bloody diarrhea, so a little bit more severe. Now, it can cause what is called hemolytic uremic syndrome, and this is a severe, as the name implies, hemolytic anemia that is leading to that blood, the release of especially bloody diarrhea. Ultimately, though, it can cause kidney damage and failure and can be life-threatening. So that hemolytic uremic syndrome can result from this STEC infection. Now, the toxin, as the name implies here, is caused is called Shiga toxin because it's the same as what's produced by another microbe that can cause acute diarrhea, Shigella, but it's the same exact thing. What's really unique about this is the reason that E. coli can make the Shiga toxin is from a bacteriophage. Okay, so remember bacteriophages can help transmit that horizontal transfer, so it can take genes from one microbe to another. That's what's happened here. So a bacteriophage infection was actually able to transfer the genetic information to make the Shiga toxin from the Shigella to this type of E. coli. So again, that horizontal gene transfer being shown to have an effect here in E. coli. The transmission of this STEC is through ingestion of undercooked beef, but also other contaminated foods and beverages, which is kind of a common theme that we'll see as we move through these. Now, some other types of E. coli. So there's enterotoxigenic, enterovasive, enteropathogenic, enteroaggregative, and then diffusely adherent. And then they all have their own little acronyms that go with it. I don't care that you learn what each one of these. You may have heard of some of these, like traveler's diarrhea, and some others. So we have chronic diarrhea, especially with individuals with AIDS. Again, just understanding there are multiple types of E. coli infections, and they all range in their severity and their virulence factors. Now, the most common cause of bacterial diarrhea in the U.S. Comes from Campylobacter. And Campylobacter jejuni is a slender, as we can see here, kind of looks like a comma, that Vibrio shape. It is gram-negative, and it has a flagella on one end, so it's called polar flagella. So it's motile, it can move. It comes from ingestion of those contaminated beverages, like water and milk, but also from meat and chicken. And this can also lead, though, to a serious paralysis called Guillain-Barré syndrome. Another one we talk about, this comes back to our antibiotics, C. diff, so Clostridioides difficile. This is a gram-positive. This is a spore former, forming rod. This is part of the normal flora, part of our normal biota. However, whenever we get antibiotic treatment and we start killing off some of those normal flora, this is one that kind of becomes overcrowded. It overproliferates, goes through more reproduction than normally occurs, and can lead to an infection. So it leads to this antibiotic-associated colitis. Again, it's due to treatment with broad-spectrum antibiotics, again, inhibiting other normal flora and allowing this one to take over. It's able to cause pathogenesis because it produces two toxins, A and B, and that causes necrosis or death of the intestinal lining. So it is treated by withdrawing those antibiotics, using a couple different antibiotics to bring this one back in check, but also a really gross but effective treatment, which is fecal transplant. And what the fecal transplant does is essentially a way of putting the normal biota back into the gut so that those levels come back to normal and keep the C. diff in check. And this is showing kind of our normal colon here, and then one in which is infected with C. diff. So causes huge amounts of mucus to be released, lots of inflammation, lots of problems with this type of infection. Now, two non-bacterial causes of acute diarrhea. One is rotavirus. So this has an RNA genome, has an inner and an outer capsid, so it's kind of a weird virus here. This causes a lot of morbidity and mortality from diarrhea. So again, Salmonella is kind of the most deadliest as far as bacteria. Rotavirus, though, is the deadliest for the non-bacterial forms. So it is transmitted by the fecal oral routes from contaminated foods. Children are treated with ORT. And then there are also a couple attenuated vaccines that are actually available. And then norovirus, as we mentioned before, is the most common cause of foodborne disease in the U.S. So this is transmitted by the fecal oral or from contaminated foods. It causes, of course, diarrhea, acute meaning short term for about 3 to 5 days, sometimes with fever or sometimes with vomiting. It has a low infectious dose, just meaning it doesn't need a lot of it to cause an infection, 1 to 20 viruses. And again, those outbreaks on cruise ships are more likely to occur. And then our summary tables here. So again, Salmonella and the STEC, so that's Shigella toxin E. coli or O157H7, coming back to those antigens. Again, both of them come in from food or beverages, but also from the fecal oral route can occur. Salmonella has those adhesions and produces endotoxin. Again, it's gram negative or has that LPS. So then the Shiga toxin E. coli obviously produces the Shiga toxin that causes damage to the intestine. And then our prevention, again, just good hygiene here and proper cooking of our meats. To them, again, some of the distinctive features here. So Salmonella, again, chicken and reptiles typically are carrying that. And then the Shiga toxin can produce that hemolytic uremic syndrome. A few others, again, there are other E. coli's that can cause that, the Campylobacter and then the C. diff are ones. Again, C. diff is endogenous. It comes from our normal biota, so it happens after antibiotic treatment, but it produces those enterotoxins A and B. Again, Campylobacter, one of our most common. Here again, food and fecal oral modes of entry can produce those adhesins to allow it to attach, produces an exotoxin there as well, and can actually has been shown to induce some autoimmunity. And then our non-bacterial, so rotavirus and norovirus. Again, rotavirus more severe, norovirus more common. So again, vehicles can be from direct or indirect contact. Again, these actually, the rotavirus has a vaccine that's available because it is so harmful. Not so much with the norovirus, so just proper hygiene is important for preventing those. Our next category here is still acute diarrhea. However, this is with vomiting due to exotoxin, and this is where we're talking about food poisoning. So to differentiate, this is intoxication, so the presence of toxins versus an infection. So it's not so much just the multiplication and the presence of a microbe, but it is the toxin released by those. And sometimes the toxin itself is ingested more so than the microbes. So again, it's exposure to the toxin from microbes, not so much the ability of the microbe to grow and produce an infection in the body. The symptoms are similar though. So we have nausea and vomiting, typically accompanied with diarrhea. So they look very similar, but again, this is due to, they're caused by that exotoxin. So it's a toxin that has been released by the microbes, usually, again, can come from non-microbial sources, so like fish, shellfish, or mushrooms. But again, this is an intoxication. It's consuming toxins more so than consuming the microbe itself that leads to an infection. So the ones we talk about here are Staph aureus exotoxin. So goes along with like our custards, cream pastries, chicken salad or ham. Of course, Staph aureus we've talked about before has that high salt tolerance that's typically used in food processing to keep them at bay, but it can survive in those. And it can produce that enterotoxin that's heat stable, but causes nausea, vomiting, and diarrhea. These are going to happen much faster. So typically intoxications have a quick onset, whereas an infection takes longer for the microbe to set up camp, to cause the disease. So those that occur very quickly are typically intoxications. These are self-limiting though, so antibiotics aren't needed because again, within 24 hours, the immune system has eliminated that toxin. So some of the other acute toxins, so Staph aureus, the main one we're talking about, but also Bacillus cereus, exotoxin, and Clostridium perfringens. Both of these are spore formers. So again, in improperly canned or produced food, those spores are going to not be removed. And then whenever these actually start reproducing, they produce these exotoxins. And again, exposure to those toxins through food leads to the acute diarrhea and vomiting. Again, both of those being spore formers, but again, it's the toxin here. And just a quick recap, we've already talked about Clostridium perfringens because this is what causes gas gangrene. Here, though, we're talking about food intoxication and food poisoning, again, being able to produce toxins that are then ingested. Then going into our chronic diarrhea, so the definition here, this is lasting longer than 14 days. So acute, of course, short-term, few days, even up to a week, but any diarrhea being more than 14 is considered chronic. So this can be from infectious or non-infectious causes, so like irritable bowel syndrome or ulcerative colitis. So microbes here cause chronic diarrhea in otherwise healthy individuals. So again, this is talking about not another kind of side problem, but this is due to an infection is what we're focusing on now. So the ones that can lead to this chronic diarrhea, so one of the E. coli we already mentioned with acute can also lead to chronic. So the enteroaggregative E. coli, the EAEC. Again, this is more chronic disease, especially in kids. So it adheres to cells and it causes aggregation, hence the name, but it causes these cells to kind of clump together rather than being in a single layer. So almost like a tumor starts to form with these. So it starts aggregating them together, but it stimulates a lot of mucus to be produced by the gut that then causes other problems. Again, transmitted by food and water. Another one, this is actually a protozoan. So Cyclospora citinians. Sorry, so this is one of the protozoan pathogens we're starting to see more of. So lots of different outbreaks in the US and Canada. We have a fecal oral transmission from produce and water. And again, protists can form cysts, which are kind of a dormant state, not as dormant or resistant as endospores, but a dormant state. And then they can come out. Part of their reproductive life cycle, they have oocysts, and these can actually be seen whenever they're exposed to UV, but it causes watery diarrhea, stomach cramps, bloating, and some muscle aches. So again, our two that we're kind of focusing on here, so the EAEC and the Cyclospora, of course, E. coli being bacterial, Cyclospora being protist. As far as, again, not a whole lot here on the EAC. With all of these, though, with all of the diarrhea, the treatment is that rehydration. In some cases, antibiotics, but replenishing fluids and electrolytes is the main treatment for all of these types of diarrhea.